Hi guys, today's lecture is on basic mathematical logic. We will be talking about implications today and necessary sufficient conditions. So, before I start with what an implication is, what we need to understand is here we will be talking about propositions. Now, the question arises, what is a proposition? A proposition is any statement that is either true or false. So, you don't have any gray area in between. So, any statement which is either true or false is called a proposition. So, you propose something, it's either true or false. Simple. So, anything like, I'm giving you a mathematical expression, anything like this, say x square minus 4 equals to 0. Now, this is an equation which will be true for certain x's, which might not be true for certain x's. Clearly, you can figure out for what x's this will actually be true. So, you can clearly figure out x square needs to be equal to 4, which means x is either plus 2 or it is minus 2. Both values will give you 4 if you square them. Now, any other value of x that you will put in, the statement will become false. So this is clearly a proposition. So a proposition is either true or false. So suppose we have two propositions. One is P and another is Q. Suppose you have two propositions with you, P and Q. So here we are talking about implication. So we say that P, a proposition P implies another proposition Q. So what does it actually mean? It basically means that whenever P is true, this means that whenever P is true, Q is necessarily true. Q is necessarily true. Q is essentially a consequence of P. P implies Q or Q is implied by P. That means Q is the consequence of P. So whenever P happens, then Q happens. And this arrow actually, this arrow sign, it tells you basically the direction of the logical implication. What is implying what? So if P is implying Q, the arrow will be like this. If Q is implying P, that would basically mean the arrow will be like this. This is P implies Q and this is Q implies P. Which essentially is, as I've already told you, whenever P is true, Q is true. So this statement here that you see is if P, then Q. And this implication, the other way around that I've written here is if Q, then P. Because that other statement means that whenever Q happens, whenever Q is true, then P is true. So these are also called if and then statements. These are conditional statements. So you always have a condition. So you have a condition if P, then Q, right? Now implications are like, for example, okay, let me give you certain examples here. X is greater than 3 implies x square is greater than 9. That's an implication because whenever you will take x greater than 3, the square will always give you more than 9. So that's implied by, this thing is being implied by x is greater than 3. Similarly, if you take x, y, the product is equal to 0. This would imply either x is equal to 0 or y is equal to 0. This will automatically imply this, right? Then another example, let's take another example. Suppose S is a square. My claim is that that implies S is a rectangle. So are you getting the logic behind it? In case you pick a square, it automatically is a rectangle, right? It has 4 sides. It has 4 equal sides for that matter. That's an additional property, but it has 4 sides. It's a rectangle and the sides are parallel to each other and 90 degrees, right? Now, another example, we can take more common example that we can, any layman can probably understand. So she lives in New York implies she lives in the US. Isn't that so? If you get to know somebody is living in New York, doesn't that imply that that person is living in US? If you get to know somebody is living in New Delhi, won't you get to know that that person is living in India? So this is a logical implication, something that you get to know. If P is true, then automatically Q is true. That means Q is being implied by P. It's a consequence of the proposition P. Okay. Now let's think the other way around. So the other way around would mean we're talking about Q implies P. Will it be correct for me to say, let me just start with the examples that I have given you. So will it be correct for me to say that Q implies P here? Will it be correct for me to say that? So I'm starting with a question mark here. So is it correct if I write x square greater than 9 implies x greater than 3? Will this be correct? And the answer is absolutely no. This won't be correct. Why? Because you can always take a counter example. You can actually fetch a counter example. Let's pick any value. Let's take x square as 16, which is greater than 9, right? And suppose this 16 was coming because I had taken x as minus 4. So you know that minus 4 square is equal to 16, which is greater than 9. But is minus 4 greater than 3? Our claim was then x is greater than 3. But then is minus 4 greater than 3? So minus 4 is less than 3. So that means this implication, if I write x square greater than 9 implies x greater than 3, could be countered. I've just given you one counter example. Always remember, to counter something, one example is good enough. To prove something, you have to prove each and every case, or whatever cases are possible. But to counter, just one example is good enough. So hence this is not true. This implication is not true. Okay. On the other hand, in case I would have started off with a case wherein I was taking minus 3 also in consideration. That is all the x's. I can say that x square greater than 9 implies that you're talking about all the x's that are lesser than minus 3, or either they're lesser than minus 3 or they're greater than 3. Then this would have been correct. This is correct, but previously if I just write greater than 3, that's not correct. Okay. Let's also take the other examples that we have. What about this one? xy equals to 0 implies either x is 0 or y is 0. The other way around, will it be true if I say that x equal to 0 or y equal to 0 implies x into y is equal to 0? Is this correct? This implication is correct because you've taken both the cases. X equal to 0 or y equal to 0 or both. Whenever you're talking in maths, when you're using or, it's an inclusive term. So or both is already included there. If or both is not supposed to be included, it has to be mentioned separately. So x equal to 0 or y equal to 0 implies xy equals to 0. This is a true implication, which means that in particularly this statement, P implies Q is happening and Q is also implying P. So P implies Q and is implied by P. Now this is a very special situation. This situation is a situation of equivalence. So this situation where P implies Q and Q implies P. This is a situation of equivalence, which basically means both the statements mean the same thing. Both are conditional statements and both mean the same thing. So whether I write P or Q, both are basically implying each other. So they are equivalent statement. An equivalent statement is written as both way arrow, because both way. The implication is happening both ways. So you have two arrows on both the sides, because P is implying Q and Q is implying P. So you have two directional arrows, because that's what is happening here. Now, so I can clearly say that the second example that we had taken, in that example, it is an equivalent relation. So it's an equivalence relation, or both statements are equivalent to each other. So we can say that. What about the third? Will Q also imply P here? Absolutely not. If S is a rectangle, it might not be a square, because for rectangle you do not have the restriction of equal sides. For square you do. So the other way round, it doesn't happen. So this is not equivalent. Also, again, a logical statement. She lives in New York implies she lives in the US. Or the other way round. So other way round, the implication would become she lives in the US implies she lives in New York. Absolutely not. If she's living in the US, she could live anywhere apart from New York as well, right? So she could live in Seattle or anywhere else for that matter, right? So even this is not equivalent, right? So there is, in certain sense, a necessary part and a sufficient part to an implication. And that's what now I will talk about. So let's talk about necessary and sufficient part in any implication. So suppose you have an implication P implies Q. Reminding you again, P and Q are some propositions. It could be any propositions. I've already given you examples, but these are the generalizations that I'm taking here. So P implies Q is a general implication that we have in hand. Now I want to ask you certain questions. So my question to you is, there are certain statements and we must be very cautious while using that. P is necessary for Q. Q is necessary for P. P is sufficient for Q. Q is sufficient for P. These are four different statements, okay? Necessary and sufficient, they are two parts of the same implication, but they both are two different parts to an implication. For example, you need to understand this very thoroughly, because you know what happens is, in case it's written P is necessary and sufficient for Q, this is the most simple thing that you will need to ever prove, because this means you're talking about both way implication. So you have an implication P implies Q, which is the necessary part of an implication, which is a sufficient part of the implication. That's what we need to understand here. And let's understand it by an example. So let me give you a couple of examples. Living in New York is necessary to live in the US, or living in US is necessary to live in New York. Which one do you think is the correct? Clearly the second one is correct, right? Living in New York is not necessary to live in the US. But living in US is of course necessary condition for me to live in New York, right? So, which basically means this is what is necessary. So, you need to understand what is the necessary part of an implication and what is sufficient part of an implication. So, if I now rewrite it in terms of an implication, what implies what? So, if I'm living in New York, that automatically implies I'm living in the US. But if I'm living in the US, that does not imply from any sense, from any logical sense, that does not imply that I must be living in New York, right? So, which means living in the US is necessary for me to live in New York. So, for any implication, P implies Q. Logically, Q is the necessary. Q is the necessary part of the implication, whereas P becomes the sufficient part. You can feel it yourself in this example. So if I am living in New York, you get to know that I am living in New York. Doesn't that automatically implies that I am in US? So that basically means that it's a sufficient criteria for me to be in US, right? So P is the sufficient part for any implication. P is the sufficient part of any implication, and Q is the necessary part of any implication. I'll give you another general example. Air is necessary for us to breathe, right? Or to be living. I need air to breathe, to live, right? So, air is necessary. That means if I'm breathing, that automatically implies that there must be air. If I do not, if there is no air in the atmosphere, if there's no air, I won't be able to breathe or to live, right? So breathing implies there is air. But does air imply breathing? Is air sufficient for me? Not just breathing, I mean here basically that I am living, I'm surviving. Does air, is it sufficient? No, it's not sufficient. I need water, I need food. There could be n number of things that are required. My organs should function properly and blah, blah, blah. So there are many more conditions that would be required for it to become a sufficiency for me to be living, to be surviving, right? So air is necessary for me to live, but it's not the sufficient criteria for me to be living. So air is necessary. It is the Q part of the implication. Breathing implies air, or living. Instead of breathing, let me just put it, living or surviving implies that there is air for me to breathe, to be able to breathe. But just the existence of air would not imply that I would be surviving. Okay? So this basically means that air, if I take up the implication that I am living, I'm a living being, that implies there must be air to breathe, right? So if I am living, automatically that tells you that there is air for me to breathe. That means breathing or living is a sufficient condition for me to know that there is air to breathe, while air is necessary for me to live. Okay, so every implication or every conditional statement has a necessary part and a sufficient part to it. You need to understand it thoroughly. You need to basically understand, in case it's written if and only if. So when you have a double implication like this or equivalence like this, this basically means you have if and only if relation, if and only if relation here. Okay, it's also written as IFF. It is also written as IFF, if and only if, which is basically equivalence. This basically means P is necessary and sufficient for Q. If P is necessary and sufficient for Q, Q is also necessary and sufficient for P. That is why this is an equivalent relation. So when equivalence is there, it's simple for you to prove. If you were asked to prove that, prove necessary and sufficient, you have to prove both the implications, right? P implies Q, Q implies P. But if it's just written, prove that P is necessary for the existence of Q, you need to know what implication you are working with. You need to know what implication you have to start with. What will be your hypothesis? What is the consequence that you require, right? So P is necessary for Q is Q implies P. P has to be the necessary part. If P doesn't happen, then Q doesn't happen, okay? And in case it's written P is sufficient for Q, that means you're talking about